sitting right on the top. Thank you, Shirke Saab, for this presentation. I now invite our next speaker, Mr. P. Surya Prakash, to give an overview of Oslo Part 2. And Mr. Surya Prakash, as we all know, is an eminent engineer, consultant, and a mentor who has made significant contributions to civil engineering. He has, I think, formed an organization, Satyavani, which is doing a great work. He has also authored a book on design and implementation of communication towers. And he is also a member of Institution of Engineers Council, the council member. Over to you, Mr. Surya Prakash. You have 30 minutes.
Thank you, Alokji. Good morning, good afternoon to all the delegates here, physically and virtually, and dear speakers, my fellow speakers. Today, I'm going to share my experience attending this FIB Congress in Oslo during June 12th to 16th. And it was a very great experience. Actually, I must thank IMC FIB for giving me this opportunity to attend and share my experiences today with all of you. Oh, you have to switch on. Okay. Okay. So my overview is about introduction, keynote lectures, and structural design topics that are presented, and India construction report. Briefly, I'll touch upon what my contribution is in the report. And we are the people, along with the President and Secretary General, Sisir Banerjee Saab Chairman, and Umesh Ji, and I missed him in the photograph, Sandeep. Okay, next. So Symposium Organizing Committee, next, and the FIB Fellows, FIB recognizes as fellows the people who have done great contributions to whether it is model code or the research. Next. And awards also are given to the people who have contributed, and the awards presentation was part of the Congress. Next. And next, please. This is all the presentation we have seen by the President also, the research that is done and awards that are presented. Yeah, you can stop here. My main observation or challenges that I had before attending this Congress were, we all know the sustainability is a thing of need for the day. And as mentioned by Umesh Ji, in fact, I have observed in Hyderabad, for example, in the last 100 years, 1901 to 2000, if there are 4 peaks of 100-year peak flood and rainfall, in the last 20 years, in Hyderabad, there are 4 peaks of beyond 100-year rainfall and flood, and it is occurring more often. So the need for sustainability and reducing carbon footprint is undebatable. And I'm happy to share I have been working on this for the last 14 years. And my question was, what is the alternative to concrete? What is the alternative to steel as a material? And the formwork, basically. We are all using, I mean, we see a lot of wastage in the formwork. Though we talk about 100 repetitions, 300 repetitions, we see a lot of scrap generated out of this formwork. So this also contributes to the global warming. So I've been thinking, what could be the alternative to formwork? And I found some answers which I'll be sharing as a present about these themes today. Next challenge was service life design. In fact, I gave a talk also recently when I was designing some project. I was asked by my client to design the building for 150 years life. I didn't have the answer actually to give a specific, and whatever I inquired, whatever I could get, the information is all prescriptive. There is no definitive formula with which I can design 100 years life or 150 years life. I'm sure many engineers face this question when we design a building, how long this building is going to survive. as per IS 456, we use in building, it is 50 years, but that too is prescriptive, subject to so many questions. So I could get some answers to this service life design also in this conference. And Model Code 2020 deals with all these parameters. And next biggest challenge I have been facing in the last 20 years as a professional is partial safety factors in our IS 456, 1.5 dead load, 1.5 live load. That's what we take. And there is so much of work behind that 1.5, arriving at 1.5. Different codes give different factors actually. But my question has been, suppose I do a building using a normal packaged wood actually, which has the tolerance of 5 to 10 mm in the levels or verticality or horizontal dimensions and all that. At the same time, I use the aluminum formwork, designed formwork, engineered formwork for the same building where my tolerance is 1 mm or 2 mm. Why my partial safety factor doesn't change with the better tolerances? I mean, what are stringent tolerances that I'm using? Next question is, I construct the building using a precast technology. Again, precast technology has got its advantages in terms of tolerances and the quality of the materials, but still our codes don't give a different values of these factors. So there is some uncertainty modeling research that is happening across the world. I hope the present, our IS 456 revision is going to adopt this in this performance-based design. Based on the targets that we set, including the tolerances, we'll be able to achieve that. So I could get this partial safety factor. Another question is, we certify the existing buildings, the residual life of structure actually. When I certify an existing building, this building is 30 years old or 40 years old. Should I certify the building for another 50 years using the same partial safety factors? Or should I certify the building for residual life, 10 years? So our codes are not very clear in their approach. And I'm sure any structural engineer, I have come across many peer review reports where they say that the partial safe, the interaction equation value should be 1.00 for the column, whereas it is 1.01 and hence it is unsafe. So this is the kind of reports we come across, and we don't have the definitive approach in certifying the existing buildings. In fact, I had to file a writ petition in Supreme Court challenging that report actually, that kind of challenges we have. So in this conference, I could get some of the papers which have worked on this partial safety factors also, and a definitive approach on existing structures, particularly for certifying the residual life of the structure. So these are all my findings. I thought first I'll share these important points as a technical man so that we don't miss these important points while we plunge into these Congress themes. So concrete and concrete materials, we have come across the keynote by President also. The very important alternatives and also the real serious work on reducing the carbon footprint and enveloped energy in the cement particularly. There was a keynote presented by Heidelberg Cement, which they have worked seriously on how to bring down with a target of 20% reduction in carbon footprint and energy envelope. And next is the construction methods, which I'll not get into in detail, but the service life design is a very important theme that was presented, including the durability and extended lifetime, that is for existing structures, and life cycle assessment of the buildings and monitoring and structural assessment, and strengthening and repair, of course. And main theme of Model Code 2020, which is UNDP sustainability goals, out of which 17 goals are identified to be adopted in the current construction industry. Next. So keynote lectures, we have seen innovative solutions for sustainability, contribution of concrete structure to stability, basically, and performance-based approach in model code, which Umesh has shared in detail, and validation of the harmonized partial factor. This is what I am very interested in for design and assessment of concrete structures as proposed in FIB Model Code 2020, and verification of durability of new and existing structures through the design, construction, and operational phases. These are all very, very important themes of the conference, as well as the keynotes presented. And under those sessions, the papers, the research papers presented will be working for those themes actually of the keynote. Really, I rarely come across this kind of conference where the keynotes are formulated with the theme of the conference, and the papers which are presented will be within that keynote actually. That's my observation. It's a very well structured Congress, and these are all the keynote speakers. I'll not, next please, get into the details, and next please. The structural design topics, validation of Model Code 2010 and Eurocode concrete shrinkage prediction models, and high cycle fatigue behavior of reinforced concrete. These are all some important things I highlighted because I cannot touch upon every topic in my half-an-hour time. Next, please. And structural design material models. Yeah, continue, please. And detailing design optimization of wind towers, RCC foundation systems. Optimization is a very, very important topic. And we have one paper, which I'll show some of the slides also. Next. And structural design topics, continue, please. Next, please. Yeah, you can continue until we find highlighted one. Yeah. Analytical model for pull-out and splitting failures in bar anchorages and laps. This is very, very important challenge that we face in our code also. Next, please. And transformation for reinforcing steel supply chain. This is a very, very important thing. In fact, I am also an adjunct faculty in 2 engineering colleges. I go and ask my student, what is the rate, cost of steel today? Any given location, whether it is Calcutta or Hyderabad. In fact, we face these challenges in projects also. In DPR, whatever rate we take, some of the manufacturers say their rate is uniform across the country, but the supply chain has to match with that. And we all know how much difficult it is to maintain the cost of steel and cement even. So there is a very good paper on supply chain management on steel. Next, please go back. Yeah. Social contents in civil engineering education. This is another very, very important thing, because we civil engineers are supposed to have the social connect actually. I keep telling the student, we have to be working on social challenges, reading the newspapers, and there is a very good paper on students working on social contents and also the sustainability goals. Next, please. In fact, I'm giving a lecture on 1st October on civil engineers' contribution to sustainability and smart cities. Next, please. Yeah, continue. Continue, please. So now I'll just FIB is a pleasant surprise for me when I attended this Congress about this organization, the way it is working, the setting the goals of in tune with the United Nations development guidelines, and also following the sustainability goals defined in the UNDP, and then formulating the research structure. Next. By formulating the model code, which will be guide to this codal provisions. Next. And formulated guidelines in line with the UNDP targets on sustainability development goals. Next. And most of the papers presented are the outcome of research, which is guided by the model code requirements and framed and allotted to the respective universities based on their specialization. In fact, FIB guides the research actually. So there is the same model can be emulated in India. This is what I found actually. I learned from this conference. Next. And IEI, organizations like IEI can take lead in regulating the research and assist Bureau of Indian Standards in reforming the code provisions and structure the codes of practice. We know there are 2,300 codes for civil engineers actually. Whereas what is taught in college to the students, if you ask any student, what are the codes you know, at the most with difficulty, you'll say IS 456 and IS 800. He doesn't even know 875 or 1893. So there are so many codes. Actually, there is no need, like model code and Euro code. We can have a single code connected with structure, single code connected with civil engineering, like that. And we should restructure this, and I feel, should take lead in formulating this. Next, continue fast. So sustainability, this is a paper keynote given by Mayor of Oslo, actually, Executive Mayor. And he talked about sustainability more than what I know, actually. That is a very pleasant thing. And continue, please. Growth in, these are the sustainability goals which the data is presented based on. I'm sorry about quality of the slides because these are all the photographs I have taken on the screen. And this is finally the concrete 2.0. That is, these are the, go back, please. This is the contribution to carbon footprint. And for the sustainability goals, no poverty, zero hunger, good health and well-being, all these are defined in UNDP sustainability goals. Next, please. Continue, please. This is a keynote about, these are all the countries contributing, and these are all some of the papers actually which I have attended. Cracked concrete, active tension. This is a new topic, so I have come across which will be very useful for assessing the capacity of the cracked concrete, considering the active tension. Next. And I'll not go into the details of all this paper because time will not be adequate. So these are all the. Next is fiber reinforced concrete. Another very, very important thing. Of course, in India also we have been using, but not to the level of structural efficiency of the concrete. In fact, yeah, please continue. The papers presented, and next is the fatigue actually. Fatigue behavior also, there are very good research works that are done. Continue, please. Next. And alkali silica reaction. This is another big challenge we are facing in the concrete assessment. Next. Continue, please. And the shear critical columns. This is another research paper that is presented. Continue, please. And detailing, as I mentioned. Optimized section using fiber reinforced concrete. And this is the research paper presented by keynote by President actually. Next is keynote on model code, which is covered by Umesh ji. Next. Please. Sustainability perspective. Basically, the cement production, actually, how seriously the industry is working, we have to bring it to our Indian. In fact, they should mention the target carbon footprint reduction in cement manufacturing, and we engineers should recommend the cement based on not only on grade 53 or grade 43 and all, but also on carbon footprint of the cement manufacturing. Performance-based design is covered. These are all the papers presented on performance-based design. And partial safety factors for assessment of existing structure. This is what I was telling. In fact, I had this question in my mind for quite long. And during this conference, I could get an answer how we can assess the residual life of the structure, considering the state of the structure and with realistic partial safety factors. Durability assessment. We all do this carbonation and extent of carbonation that and corrosion to the reinforcement, but there is a definite method given for assessing the residual life of the structures. This is service life design. This is another definitive method that is proposed in the model code for life of the structure and which we can make use of. Next, post displacements, some of the research papers, and precast concrete, pre-stress concrete. There is a lot of good work happening and all these are presented. This is, please, yeah. Optimization and 3D printed recyclable formwork. This is another challenge I was talking about. This is a pleasant surprise to me, where they have developed the geometry of the structure using the optimization principles. And normally I have been doing optimization based on parametric optimization, but this is a topology. Using the topology, they developed the shape of the structure, and for that shape of the structure, they identified the formwork. You can see on this right side, the formwork is 3D printed, and so that it can be recycled. The composites can be recycled, so formwork is not at all wasted at all. Next, please. Precast concrete and sand formwork. Yeah, this is another interesting paper that I have come across for complex structures. Basically, you optimize the structure, but whenever we optimize the structure, the challenge we face is about the formwork cost, whether it is shells or all that. So what they have done is they have developed this using the sand with some chemical. They will create the formwork, and once the structure is cast, the sand is again recycled. So, this is a very interesting paper I have come across, and you can continue, please. The sand formwork. This is the structure. Go back, please.
Surya Prakash,
yeah.
you have just
I'm coming to end. Yeah, next, please. Continue. Don't stop. Fiber reinforced concrete. Very interesting papers. Sustainability goals and. This is the national report. Please go back. I just took 2 minutes and conclude. This is a national report on concrete structures presented by us in the sessions. 7 countries have presented, and we definitely stand out in all the presentations. Next, please. I'll just, yeah, this is the project. We contributed. Back, please. Back. Just go back. Yeah, this is only one project. I'll just explain. This is a housing project which we have done in Hyderabad, 4,000 houses to be completed in 12 months at a cost of 1,280 rupees per square feet, 11-storied, where we adopted as a risk mitigation 3 technologies in the same project. And we shared that in the compendium. And this we completed in time without any cost escalation, but with a saving. And last 4 towers we completed in 4 months, 11-storied. So this is a project which is part of our compendium. Next, please. This is another project, 7 runways of 900 crore project in Arunachal Pradesh, state of Arunachal Pradesh, which we completed in 30 months in the given time without cost escalation. These are the projects we contributed in this compendium. So thank you very much. And if there are any questions, we can. Thank you.
Thank you. Thank you, Mr. Surya Prakash, giving a helicopter view of what transpired at Oslo. Practically, you have scanned through the entire proceedings and highlighted some of the papers which is related to topics of your interest, like service life design, reducing carbon footprint, life cycle assessment, fatigue, sand formwork, and etc. A lot of things to learn, and I think this kind of interaction in the form of FIV days helps to close this gap between the research and the practice. It is an excellent kind of a platform, and I would very much like to have similar kind of interaction in even other international conferences. Somebody attends, he comes here, and he can share what transpired there. So thank you once again, Mr. Surya Prakash.
One or two suggestions. The Institution of Engineers is a member of FIB and institution gets all the documents, including the journals, bulletins. I hope so. And they must be all in the hard copies should be available in your library. Okay, and these bulletins and journals are excellent documents. So whoever is interested in and around Calcutta, they can visit a library, glance through those documents and make a use of it. They are extremely important documents. This was the latest one.
I think let's.
Yeah, in fact, I collected all the journals. I can share it to headquarters actually.
Yeah, okay.